Hello there, and welcome to Edge of Mind. Tonight, we are going somewhere you have already been your entire life. Somewhere so enormous that the word enormous doesn't quite reach it. Somewhere you will never be able to step outside of and look back at. Not tonight, not ever. Hold the image in your mind. A clear night, the air still, and above you, if you are somewhere far enough from the glow of city lights, a faint smear of pale light stretching across the sky from one horizon to the other, soft, almost like something left behind. Most people, when they notice it at all, assume it is clouds, or haze, or some trick of the atmosphere. But it is not any of those things. That smear of light is 400 billion stars, and you are inside it. Not looking at it from some comfortable distance, not observing it from a safe remove. You are nestled within one of its long, slowly curving arms, 26,000 light-years from the center, on a small and quiet world, looking outward through the body of your own galaxy. Every single one of those faint points of light, scattered across that pale band, is a sun. Many of them have worlds of their own, and all of them, every last one, are your neighbors, in the way that the word neighbor stretches almost beyond meaning. And before we go any further, I'd love to know where you are right now. What part of the world are you watching from tonight? Whether it's late where you are, or just getting quiet, drop it in the comments. It's always so lovely to see where these evenings find people. Now, here is the thing that quietly changes something, once you really let it settle. Every photograph you have ever seen of a beautiful spiral galaxy, those sweeping arms of luminous stars curving outward from a glowing center, the whole structure hanging in the dim of space, like something woven from light, that is not our galaxy, that is someone else's, a neighbor of ours perhaps, or something far more distant, but not home. We have never seen our own galaxy from the outside. No human has, no instrument we have ever built has. The Milky Way is so vast and we are so thoroughly embedded within it, that seeing it whole, the way you might see a city from a hillside above it, is simply not something our species has ever done. Not in your lifetime, not in the lifetime of everyone alive on this planet right now. Not in the lifetime of our species, as far as we can imagine forward into the long, unhurried future. We live inside something so enormous we cannot even look at it. Most of us move through our days without any awareness of this at all. The galaxy is simply there, the way the ground is there, present, constant, unnoticed. We wake and we sleep, and we go about the small and meaningful business of our lives. And all the while we are passengers inside a structure containing 400 billion suns, rotating slowly through a universe so wide that the numbers used to describe it stop feeling like numbers and become something more like poetry. The Milky Way is shaped, as far as we can determine, like a flattened spiral, 2 major arms and several smaller ones, curving outward from a dense and luminous center. The whole structure is roughly 100,000 light-years across. A single light-year, the distance light travels in 1 full year, moving at the speed that nothing else in the universe can match, is about 6 trillion miles. When you multiply that by 100,000, you arrive at a number the human mind was simply not built to hold. It is easier, and perhaps more honest, to simply say, very, very wide, wider than anything you have ever tried to picture, and then wider still. Our solar system sits near the inner edge of a region called the Orion Arm. It is one of the smaller, quieter arms of the galaxy, not one of the grand sweeping structures closer to the center. We are, in galactic terms, somewhere in the middle distances, not at the heart of things, not at the far outer edge, somewhere between, in a region that has been calm enough to allow over billions of years the slow and patient emergence of something like life. The center of the galaxy lies in the direction of the constellation Sagittarius. On summer evenings in the northern hemisphere, the Milky Way appears thickest and most luminous in that part of the sky. Looking that way, you are looking toward the densest and most ancient part of your home, toward the place where everything is older, more gathered, and stranger than anything out here in the quieter arms. At the very center of all of it, at the heart of the Milky Way, hidden behind vast clouds of dust and gas that no ordinary light can pass through, something sits, something enormous and still. Something that was there long before our sun existed, and will remain long after it is gone. For now, it is worth simply remaining here, with the basic shape of things, with the image of a spiral, slowly turning, with the knowledge that you are on one of its arms, far from the center, on a world that is itself moving, not sitting still the way it feels, but moving always in great sweeping arcs through the body of the galaxy. As you sit or lie wherever you are traveling. The Earth moves around the Sun moves around the center of the Milky Way, and the whole galaxy moves through the wider universe. There is no stillness, anywhere, at any scale. Only motion at different speeds, in different directions, all of it so gradual and so vast that it feels, from where we are, like perfect quiet. The Sun's journey around the center of the galaxy takes a very long time. One full orbit, one galactic year, some scientists call it, takes approximately 225 million of our years. The last time our solar system was in this same position, the Triassic period had only just begun on Earth. The first dinosaurs were finding their way across a world that looked almost nothing like the one we know now. The continents were arranged differently, the air was different, and here we are, one full lap later, still on the same slow path, the Sun carrying us forward at a speed of 514,000 miles per hour, steadily, silently, without any sensation of movement at all. That speed is worth sitting with for a moment. 514,000 miles per hour. That is how swiftly you are moving through space, simply by being here, not because of anything you did, not because of any engine or force you can feel, simply because you are part of a solar system that is part of a galaxy that has been slowly turning for longer than the Earth has existed. There is something quietly humbling about that. Something that makes the ordinary concerns of a day feel very small, and at the same time somehow very precious. You are here, moving through the body of a galaxy, on a world that has, against all the vast and indifferent odds of the universe, managed to hold on to the conditions that allow something like awareness to arise and look up at the night sky and wonder. The ancient light falling from that pale smear overhead has been traveling for years, for decades, for some of it, centuries, just to arrive on this particular evening. The galaxy is not something distant. It is not something you are observing from afar. It is something you are inside, something you are part of, something that has been carrying you, without pause, since the moment you were born, and we have only just begun to understand what it actually is. In the parts ahead, we will move deeper into this place, toward the silent invisible mass at its center, toward the oldest stars still glowing in its outer reaches, toward the strange and invisible material that holds the whole structure together, without ever being seen. We will follow the slow movement of the galaxy through time, and look ahead toward something that is already on its way, a neighbor, vast and unhurried, moving toward us, across a distance that makes the word far feel entirely inadequate. But for now, there is just this, the faint smear of light above a quiet world, 400 billion stars, and you, somewhere inside all of it, already home. At the heart of the Milky Way, something waits in the dim, patient, enormous, and entirely invisible to the naked eye. Not a star, not a cluster of stars. Something far stranger than either of those things. A place where the ordinary rules that govern light and motion and time begin to soften, and then, at a certain threshold, stop applying altogether. We call it Sagittarius A star. It sits at the very center of our galaxy, hidden behind layer upon layer of dust and gas, so dense that no visible light can pass through it. For most of human history, we had no idea it was there. The center of the galaxy was simply a direction, a thickening of the Milky Way in the summer sky, a place where the stars appeared more numerous and the glow more luminous, but nothing more than that. It was only by watching the stars near the center, watching them over years, over decades, that astronomers began to understand what was hidden there. Those stars were moving in ways that required explanation, not drifting gently outward the way stars in quieter regions do, but wheeling in long, sweeping arcs, moving far more swiftly than anything that far from a visible source of gravity had any reason to move. Something was pulling them, something was holding them in orbits so narrow and so swift that the only possible explanation was a mass almost beyond imagining, gathered into a space far smaller than our solar system, 4 million times the mass of our Sun, all of it drawn into a region you could cross in a matter of hours at the speed of light. That is what sits at the center of the Milky Way. A supermassive black hole, still and silent, detectable only by the way everything around it moves. A black hole is not a hole in the way the word suggests. It is not empty. It is the opposite of empty, a place where matter has been compressed so thoroughly that its gravity overwhelms everything, including the motion of light itself. Light, which moves more swiftly than anything else in the universe, cannot find its way out once it crosses a certain boundary. That boundary has a name, the event horizon. Beyond it, nothing that enters has ever been observed to return. Not light, not information, nothing. Sagittarius A star is quiet, as supermassive black holes go. Some galaxies have black holes at their centers that are steadily consuming surrounding material, drawing in vast quantities of gas and dust, releasing enormous amounts of energy as that material spirals slowly inward, glowing across enormous distances in a way that can be seen from other galaxies entirely. These are called active galactic nuclei, and they are among the most luminous things in the universe. Our own central black hole is not like that. It rests, for now, in a state of relative stillness, surrounded by a faint haze of gas, occasionally drawing in a small amount of material, but nothing that would signal its presence from afar. It simply sits there, waiting. In a sense, though, waiting implies intention, and there is no intention in a black hole, only gravity, which is patient in a way that nothing else in the universe quite manages to be. In the spring of 2022, something happened that had never happened before. A team of astronomers released the first image ever made of Sagittarius A star itself. Not an artist's illustration, not a diagram, an actual image, assembled from radio telescope data gathered by observatories positioned across the entire surface of the Earth, all working together as a single instrument. The image showed a ring of dim, glowing gas surrounding a region of shadow, the shadow of the event horizon, the place where light was being bent and slowly swallowed. It was soft by the standards of ordinary photography, but it was real. For the first time, the thing at the center of our galaxy had a face. It was a humble image, in a way, a small, warm circle of orange and gold against the surrounding dim, and yet what it represented was something that had taken decades of work by hundreds of scientists to produce, a portrait of the most massive and most hidden object in our own home, finally made visible, at least in part. The stars that orbit nearest to Sagittarius A star move at speeds that are difficult to hold in the mind. One of them, a star called S2, completes a full orbit around the black hole in just 16 years. Our own sun takes 225 million years to complete a single orbit around the galactic center. S2 does it in 16. Its orbit brings it so near to the black hole that the effects of that immense gravity become measurable. Its light shifts in ways that confirm precisely what Einstein's equations had suggested more than a century ago. The black hole is not a theory, it is a fact, confirmed by motion, confirmed by light, confirmed by the slow and patient gathering of observation over many years. Surrounding the central region, the galaxy grows more dense and more ancient. The stars near the center are, on average, far older than the ones out here in the quieter arms. They formed early in the first few billion years after the galaxy itself began to emerge from the vast, dim clouds of gas that filled the early universe. Some of them have been burning for 10, 11, 12 billion years. They are so old that the elements available when they formed were simpler than the elements available now. The early universe was mostly hydrogen and helium. The heavier elements, carbon, oxygen, iron, all the things that make planets and living things possible, had to be forged inside stars and scattered outward through the slow deaths of those stars over billions of years. The oldest stars near the galactic center formed before much of that scattering had happened. They are made of simpler material, and they burn with a different quality of light. Out in the halo, the wide, dim, roughly spherical region that surrounds the flat spiral of the galaxy, the oldest stars of all are still glowing. These are found in ancient clusters called globular clusters, some of which contain hundreds of thousands of stars gathered into dense, luminous spheres. There are around 150 of these clusters drifting slowly around the Milky Way. Some of them are nearly as old as the universe itself, 13 billion years in certain cases. The universe is approximately 13.8 billion years old. These stars formed when it was still very young, when the first structures were only beginning to emerge from the dim, expanding fog of the early cosmos. They have been burning ever since. Quietly, steadily, in the outer reaches of the galaxy, while everything else was happening, while the disk formed, while the spiral arms took shape, while smaller galaxies were gradually absorbed into the growing structure. They were already ancient when our own sun condensed from a cloud of gas and dust 4.5 billion years ago. Already old when the Earth formed, when life arose, when it slowly changed and spread across the surface of a world. Those distant stars had been quietly watching for longer than the Earth had existed. There is something in that image worth staying with for a moment. Those globular clusters, drifting slowly in the outer halo, are older than the ground beneath you, older than the oceans, older than the sun. And they are still there, still visible on a clear night to anyone with a small telescope, faint, soft points of light that resolve, with magnification, into something resembling a delicate smudge of luminous mist. Each one of those smudges contains hundreds of thousands of ancient suns. The galaxy holds all of this together. The ancient halo, the dense and crowded center, the quieter middle distances where we happen to find ourselves, the long sweeping arms where new stars are still forming from the gas and dust that lingers between the older ones. It holds it together, not only through the gravity of its visible stars and gas, but through something else. Something that has no name beyond a description of what it is not. That invisible something is what we will move toward next, the material that makes up most of the mass of the Milky Way, that holds the whole rotating structure in its shape, and that no instrument has yet been able to directly observe. It is everywhere in the galaxy. It surrounds us, and we have almost no idea what it is. Dark matter is the name that was given to it, though the name is more of a placeholder than an explanation. A way of saying we know something is there, even if we cannot say what it is. The evidence for it is not subtle. When astronomers measure how swiftly the outer regions of the Milky Way are moving, something does not resolve. The stars far from the center should be moving more slowly, the way the outer planets of our solar system move more slowly than the inner ones. But they are not moving slowly. They are moving far more swiftly than the visible mass of the galaxy could account for. Something is holding them in, pulling them with a gravity that has no visible source. The math only resolves when you add a vast, invisible mass distributed throughout and around the galaxy. A kind of hidden scaffolding that the visible stars and gas are simply woven within. This invisible material appears to make up roughly 85% of the Milky Way's total mass. The stars, the gas, the dust, the planets, everything that can be seen or measured directly, all of that amounts to only a small fraction of what is actually here. The rest is something else entirely, something that neither emits nor absorbs light, something that moves through ordinary matter without any apparent interaction, leaving no trace except the gentle, steady pull of its gravity on everything around it. No one has held it, no instrument has captured it directly, it has never been seen, and yet without it, the galaxy would slowly come apart, the outer stars drifting away into the surrounding void, the whole rotating structure gradually losing its shape and dissolving into something formless and dim. It is, in a quiet way, the most present and least understood thing in the place you call home. You are moving through it now, as you have been every moment of your life, without ever feeling it pass. And somewhere out beyond the visible edge of the galaxy, where the last faint stars give way to the long, open distances between galaxies, it continues, shaping everything, seen by no one, patient in the way that only very old and very vast things manage to be. The dim matter surrounds everything, the ancient halo stars, the winding arms, the dense and crowded inner regions, like a vast, invisible ocean in which all the visible parts of the Milky Way are quietly submerged. It does not glow, it does not shimmer, it gives nothing away, and yet the shape of everything you can see is a kind of shadow, cast by the shape of what you cannot. There is something worth staying with in that image for a moment. The idea that the most abundant material in the place you live is also the most completely hidden from you. Not hidden the way a distant star is hidden by distance. Not the way the galactic center is hidden by dust and gas. Hidden in a more fundamental way, as though it simply does not participate in the ordinary exchange between matter and light that makes the rest of the universe visible. When astronomers first began to notice that something was wrong with the numbers, it was not through a single observation. It arrived gradually, the way most deep realizations do. as a slow accumulation of measurements that refused to align with what the visible mass of the galaxy should have been producing. A Swiss astronomer named Fritz Zwicky noticed something similar in distant galaxy clusters during the 1930s. He found that those clusters were moving in ways their visible matter could not explain. Decades later, an American astronomer named Vera Rubin measured the rotation of galaxies in careful, patient detail. She found the same quiet discrepancy waiting inside each one. The outer regions were moving too steadily. The curve that described their motion was flat where it should have been falling away. Something unseen was holding everything in place. Rubin spent years mapping these rotation curves, galaxy after galaxy, and the result was always the same. The pattern was not an error. It was not a flaw in the instruments. It was a feature of galaxies themselves, a signature left behind by something that the visible universe alone could not account for. Her work was careful and unhurried, and it slowly shifted the way astronomers understood the structure of everything around them. What she found carried enormous weight, though it arrived without drama. If the outer stars of a galaxy were moving too steadily, and if that steadiness required more mass than the visible stars and gas could provide, then most of the mass of any given galaxy, including the Milky Way, was simply not visible, not faint, not distant, not obscured by dust. The visible universe, all the stars, all the nebulae, all the gas and planets and moons, was, in a sense, only a thin layer resting on something much larger and much less understood. What this dim matter is made of remains one of the most open questions in all of science. There are theories, some of them elegant and carefully developed over many years. Some scientists have proposed that it consists of particles that move through ordinary matter by way of gravity alone, particles that could pass through a planet the way a breath passes through empty air, leaving nothing behind. Others have suggested more unusual possibilities, some involving physics that has not yet been confirmed by any experiment. None of these proposals has been verified. The particle, if it is a particle, has not been found. What has been found, again and again, is the gravitational effect, the steady, patient pull that dim matter exerts on everything around it. This pull can be measured indirectly in several ways. One of the most striking is a phenomenon called gravitational lensing, where the gravity of a massive invisible structure bends the light coming from more distant objects behind it. The light curves around the hidden mass the way water bends around a stone submerged just beneath the surface. By mapping these distortions carefully, astronomers have been able to sketch the rough outlines of where dim matter gathers, not what it is, but where it tends to settle, how it is shaped, how it flows around and through the visible structures of galaxies. In the Milky Way, this dim matter appears to be distributed in a vast, roughly spherical region called the dark matter halo, a structure far larger than the visible disk of the galaxy, extending outward for hundreds of thousands of light-years in every direction. The visible spiral, with all its stars and winding arms, sits nested within this enormous invisible envelope, the way a small flame might sit within a very large and very dim surrounding warmth. The halo does not rotate the way the disk does. It does not have arms. It is simply there, diffuse and vast, shaping the gravity of everything within it. Moving through this halo, unaware of it, are the globular clusters, those ancient, dense gatherings of old stars drifting slowly in the outer regions of the galaxy. They move through the dim matter halo, the way objects move through any gravitational field, following paths determined by the invisible mass surrounding them. In a sense, their orbits are a kind of ongoing measurement, each one slowly tracing the shape of something that cannot be seen. There are other structures moving through the outer reaches of the Milky Way as well. Smaller galaxies, dwarf galaxies, some of them containing only a few billion stars, orbit the Milky Way at great distances, slowly drawn inward by its gravity, over immense spans of time. Some of these have already been partially absorbed, their stars drawn into long, faint streams that trail through the halo, like something unraveling very slowly. The Sagittarius dwarf galaxy has been gradually pulled apart over billions of years. Its stars have been drawn into a long looping arc that winds around the Milky Way in a structure sometimes called the Sagittarius Stream, the slow, quiet remains of a smaller galaxy that wandered too near and was gradually gathered in. The Milky Way has been doing this for a very long time. It grew to its present size, not in one event, but through many slow accumulations, smaller structures drawn in over billions of years, their material absorbed into the larger whole. The galaxy surrounding us now is, in a sense, the sum of many earlier galaxies, most of them long since dissolved into the larger structure, their stars now distributed throughout the disk and halo, without any visible trace of the separate things they once were. This process is still continuing. The large and small Magellanic Clouds, two irregular dwarf galaxies visible from the southern hemisphere as faint, soft patches of light, are moving through the outer regions of the Milky Way's gravitational influence. They are connected to the Milky Way by a long, faint trail of gas called the Magellanic Stream, a structure stretching across a vast portion of the sky that marks where material has been gradually drawn away from them. Over time, they too may be absorbed, their stars and gas eventually becoming part of the larger structure, the separate shapes they hold now dissolving into something continuous and shared. The galaxy, then, is not a fixed or finished thing. It is a slow process, something still assembling itself, still drawing in what surrounds it, still changing in ways that unfold across timescales, so long that a human lifetime registers as almost nothing against them. The dim matter halo, the ancient globular clusters, the dwarf galaxies drifting in the outer reaches, all of it is in motion, all of it part of a structure that is still in its unhurried way becoming. And somewhere within all of that slow becoming, there is something else waiting in the story, something that moves in the opposite direction, not inward but outward, not gathering but approaching. A galaxy far larger than any of the dwarf companions currently orbiting the Milky Way, moving steadily nearer through the long stillness between galaxies, following a path that has been set for billions of years. It is still a very great distance away, but it is coming, and the encounter it will eventually bring is unlike anything in the current life of the galaxy. A meeting so vast and so slow that the word collision hardly seems to fit. The galaxy that is approaching is called Andromeda, and it has been moving in this direction for a very long time. It sits roughly 2.5 million light-years away. The light reaching us from it tonight, left before our species existed, before any human hand had ever shaped a stone or tended a fire. And yet, measured against the full scale of intergalactic space, 2.5 million light-years is close, close enough that gravity has already made its decision. The two galaxies are bound to each other, drawn together along a path that will not be altered by anything between now and the moment they finally meet. Andromeda is larger than the Milky Way. It holds perhaps 1 trillion stars within its spiral arms, more than twice the number visible in the structure surrounding us. From a great enough distance, if something could observe both galaxies at once, they would appear as two enormous, softly glowing disks drifting toward each other through the dim space between them, each one trailing its own invisible halo, each one carrying within it billions of worlds that may or may not be empty. The encounter, when it comes, will not resemble anything the word collision usually brings to mind. There will be no impact in the ordinary sense, no shattering. What will happen instead is something far slower and far stranger, a gradual interpenetration, two vast structures passing into and through each other over the course of hundreds of millions of years. Their stars are so widely spaced that almost none will ever come near enough to another star to interact. The space between stars is so genuinely empty that two galaxies can move through each other the way two clouds of breath might drift and mingle in cool evening air, each one slowly reshaping the other, neither one simply lost. What will change is the larger structure. Gravity will pull streams of stars into long arcing trails. The spiral arms, those slow and beautiful curves that have taken billions of years to form, will be drawn apart and reshaped. The two galaxies will pass through each other, separate for a time, and then gradually fall back together, merging over an immense span of time into a single larger structure. Astronomers have a quiet name for what that structure will eventually become. Not a spiral, something rounder, older in appearance, its stars distributed in a softer and more diffuse arrangement. That meeting is still 4 billion years away, moving toward us with a patience that makes even geological time feel brief. 4 billion years is a number that arrives without drama, and then simply sits there, too large to hold in any ordinary way, too distant to feel as anything other than a kind of abstract patience woven into the structure of the universe itself. The merger is coming. The path is already set, and yet the present moment of the galaxy, the one surrounding us right now, in all its slow and wheeling vastness, continues as though nothing were approaching at all. The spiral arms turn, the outer halo drifts, the ancient stars in the globular clusters go on burning in their soft, gathered light, as they have been doing since long before the Earth existed. There is something worth staying with in that image for a moment. Two enormous structures, each one carrying within it hundreds of billions of worlds, moving toward each other through the long stillness between them, and yet from inside either one, nothing would feel different, no tremor, no sign. The approach is so gradual, measured across spans of time so immense, that the entire recorded history of human civilization would not register even as a breath against it. The merger is real, the path is fixed, and the galaxy surrounding us now simply continues, unhurried and indifferent, turning on its axis the way it always has. What the merger will eventually produce is a structure astronomers have observed elsewhere in the universe, in places where two spirals have already completed their long, slow passage through each other and settled into something new. The resulting shape is called an elliptical galaxy, where spiral galaxies tend to be flattened and organized, their stars moving in relatively ordered paths around a shared center. Elliptical galaxies are rounder and more diffuse. Their stars move in a wide range of directions, crossing and recrossing through the interior of the structure, without the kind of shared, sweeping motion that gives a spiral its distinctive form. The organized beauty of the arms, those long, luminous curves, gives way to something older in appearance, something that has moved past the age of active formation and settled into a quieter phase. The structure is still vast, the stars are still present, still burning, but the sweeping symmetry is gone, dissolved gradually into something rounder and more still. Elliptical galaxies tend to hold older stellar populations. The gas and dust that fuel the formation of new stars has largely been used up or scattered during the merging process, and what remains is a population of stars that formed long ago, burning now in the slower, steadier way of older stellar bodies. The color of an elliptical galaxy, seen from a distance, tends toward the warmer end of the spectrum, not the blue-white of regions where new stars are still being born, but the softer amber and gold of stars that have been burning for a very long time. The structure that the Milky Way and Andromeda will eventually become has been given an informal name by the astronomers who model it. They call it Milkomeda, a quiet, almost gentle word for something so vast. Whether the Sun will survive the merger is a question with no simple answer. The probability of any individual star being directly disturbed by another during the encounter is very low, but the gravitational reshaping of the larger structure may alter the Sun's position within it, drawing the solar system into a different region of the merged galaxy, farther from the center or nearer to it, depending on the precise way the encounter unfolds. The neighborhood the solar system currently occupies, this particular stretch of the Orion Arm, with its familiar surrounding stars, and its relatively still position within the disk, may be very different by the time the merger reaches its later stages. The Sun will still be burning, the planets will still be present, but the sky above them, the arrangement of surrounding stars, the faint structure visible on clear evenings, will be something unrecognizable. The night sky during the early stages of the encounter, hundreds of millions of years from now, would be something to observe in long, slow wonder. Andromeda, which appears now as a faint smudge of light in the constellation Perseus, visible to the unaided eye on a very clear night, but only just would have grown across the sky into something immense. A vast, softly glowing structure spreading across a wide arc of the night, its spiral form gradually becoming visible, its light deepening steadily over millions of years. The approach would be imperceptible within any single lifetime, or any single 1,000 lifetimes, but across the deep spans of time involved, the sky would slowly fill with it, the far galaxy becoming nearer, becoming larger, becoming something that would dominate the view from any world within the Milky Way. And then the interpenetration would begin. Streams of stars drawn into long, arcing trails, extending away from both structures. New regions of star formation would stir as vast clouds of gas were compressed by the gravitational interaction. Brief, luminous moments of stellar birth, in the midst of the slow, enormous reshaping. The arms of both galaxies would be distorted, stretched, pulled gradually apart from their original forms, all of it unfolding across timescales that no living thing could witness in full. Only the very beginning of one stage, and then the very end of another, with everything between invisible to any single observer. There is a particular kind of galaxy that shows exactly this. Caught mid-encounter, its arms stretched into long tidal trails, its structure visibly altered. Astronomers have found many of them, scattered across the observable universe, each one a still moment in a process that takes hundreds of millions of years to complete. The antennae galaxies are two spirals currently in the process of merging. They show long, streaming trails of stars extending away from the central bodies, arcing outward into the surrounding space, like something slowly unraveling. Seen in images, they are among the most visually striking structures in the known universe. And they are simply doing what the Milky Way and Andromeda will one day do, in their own time, along their own path. The universe is full of these slow collisions, mergers between galaxies of similar size, or between a large galaxy and a smaller companion, are a fundamental part of how galaxies grow and change over time. The Milky Way itself grew through many such accumulations, smaller structures absorbed over billions of years, their material folded into the larger whole. What is coming with Andromeda is simply the next such event, larger in scale than anything the Milky Way has experienced in a very long time, but not different in nature from the slow processes that have always shaped it. The universe is old enough that many galaxies have already passed through multiple mergers. Some of the elliptical galaxies visible in deep-field images, those ancient, amber-colored structures drifting in the far distance, may have formed through the merging of 2 or 3 or even more spirals, each one a system as large and complex as the Milky Way, now dissolved into the larger whole, their stars still present, still burning, but the organized beauty of their original forms long since reshaped into something rounder, quieter, older. There is something in that image worth resting with. All of that structure, the spiral arms, the organized motion, the regions of ongoing star formation, not lost exactly, but transformed. The stars remain, they simply move differently now, in wider and more varied paths, through a structure that no longer holds the sweeping symmetry it once had. Something is lost in the merging, and something, in a different sense, remains. The Milky Way as it exists right now, the structure surrounding us, the one we cannot see from the outside, the one we only know through patient observation and careful inference, is a spiral galaxy in what might be called its active middle age. New stars are still forming within it. The arms are still defined. The disk still holds its shape. This particular phase of its existence, the one we happen to occupy, is not permanent, but it is present, and it is real, and it is still unfolding in all its slow and enormous complexity. And within that complexity, there are things still waiting in the story, not the far future of the merger, but the present structure of the galaxy itself, the way it is organized, the way its different regions relate to one another, and what it is like in the places furthest from the familiar neighborhood the solar system calls home. The outer reaches of the Milky Way are among the least understood regions of the entire structure. Beyond the familiar disk, beyond the spiral arms with their organized motion and their ongoing stellar nurseries, the galaxy gradually gives way to something much quieter and more diffuse, a vast, roughly spherical region that astronomers call the halo. It extends far beyond the visible disk in every direction, dim and sparse, populated not by the dense concentrations of stars found in the arms, but by scattered individuals and ancient clusters drifting in wide, slow orbits around the galactic center. The stars found in the halo are among the oldest in the entire galaxy, some of them formed in the earliest period of the Milky Way's existence, when the universe itself was still very young, and the raw material for star formation was more evenly distributed than it would later become. These stars burn with a faint, steady light. They carry within them the chemical signature of a much earlier time composed almost entirely of hydrogen and helium, with very little of the heavier elements that later generations of stars would produce and scatter through the surrounding space. They are relics, in a sense. Quiet witnesses to a version of the galaxy that no longer exists in the same form. Scattered through this halo are structures called globular clusters, dense, roughly spherical gatherings of hundreds of thousands of stars, all bound together by their mutual gravity and moving as a single body through the outer regions of the galaxy. There are over 150 of them associated with the Milky Way. Some orbit in wide paths that carry them far above and below the plane of the disk before returning again. Seen through a telescope, a globular cluster resolves into something worth lingering over, a tightly gathered sphere of stars, growing denser toward the center, the individual points of light becoming almost indistinguishable from one another at the core. Within a globular cluster, the stars are far closer together than anything in the neighborhood the solar system currently occupies. The nearest star to our own sun is over 4 light-years distant. Within the densest part of a globular cluster, that same distance might contain dozens of stars. Any world orbiting a star near the center of such a cluster would have a night sky unlike anything visible from here. Not a scattering of distant points, but a soft, dense blaze of nearby light. The surrounding stars close enough and numerous enough to cast faint shadows on the ground below. That image lingers quietly, the way certain things do when the scale of the galaxy begins to slowly settle in. The outer halo is not a place most people ever think about when they think about the galaxy. It has no bright regions of star formation, no sweeping arms arranged into visible patterns. It is simply there, enormous and quiet, extending outward in every direction from the disk below, holding its ancient population of wandering stars and slow-moving clusters in a kind of stillness that has lasted for most of the universe's life. There is something about that stillness that takes a while to fully arrive in the mind. The disk of the galaxy, the part we occupy, the part with all its organized motion and ongoing activity, is itself unimaginably large, and yet the halo surrounds it, the way a faint atmosphere surrounds a planet, extending outward to distances that make the disk seem almost small by comparison. The stars out there are not arranged in any particular pattern. They simply drift, following their own long, slow paths. Some of them taking hundreds of millions of years to complete a single orbit around the galactic center. Among those drifting populations, the globular clusters hold a particular kind of quiet weight. Each one is a gathering of ancient stars so densely woven near the center that the space between them narrows to something almost intimate by cosmic measures. From a distance, through even a modest telescope, they appear as soft, luminous spheres, slightly brighter at the core and gradually fading toward the edges. Seen more closely, they would resolve into something far more intricate. Individual stars, each one old, each one burning with the steady, unhurried light of something that has been doing this for a very long time. The ages of these clusters were among the first strong pieces of evidence that the universe itself had a beginning. When astronomers measured the stars within globular clusters, some came back with ages approaching 13 billion years. The universe is roughly 13.8 billion years old. These clusters formed when the universe was still in something close to its earliest chapter, when the large-scale structures we now see had barely begun to organize themselves. To say a star is 13 billion years old is to say something the mind can register but not fully hold. The Earth is 4.5 billion years old. The Sun is about the same. Before either of them existed, these halo stars were already ancient, already burning for billions of years before the cloud of gas and dust that would eventually become our solar system had gathered itself together. They were present when the Milky Way was still forming, still assembling its disk, still finding the shape it now holds, and they are still present now, still moving in their wide and unhurried paths through the outer reaches of the galaxy. The chemical composition of these old stars tells a story worth staying with for a moment. Every generation of stars that forms and eventually ends its life releases material back into the surrounding space. That material includes elements that were not present in the original cloud of hydrogen and helium left over from the early universe. Carbon, oxygen, nitrogen, iron, calcium. All of these heavier elements were forged inside stars and scattered outward over billions of years of stellar generations, living and ending, and enriching the surrounding gas. The stars in globular clusters formed before much of that enrichment had taken place. They carry almost none of it. Their spectra, the patterns of light they emit, which reveal what they are made of, show a composition that is simple compared to younger stars like the Sun, mostly hydrogen, mostly helium, a small fraction of everything else. They are, in a chemical sense, nearly pristine, formed from material that had barely been touched by the processes that would later make the universe so much more varied and complex. The Sun, by contrast, is a third-generation star at minimum. The material it formed from had already passed through the interiors of earlier stars, been scattered, gathered again, and enriched with heavier elements. The same is true of the Earth, and of everything on it. The iron in the ground, the calcium in living things, the oxygen in the air. All of it was made inside stars that lived and ended long before the Sun existed. The halo stars missed all of that, having formed too early, in a universe that had not yet had time to build up that complexity. That difference in composition is one of the ways astronomers distinguish between the old stellar populations of the halo and the younger populations found in the disk. The disk contained stars of many different ages, formed at many different times from material that had been gradually enriched by each previous generation. The halo contains almost exclusively the oldest population, the ones that formed when the raw material was still nearly primordial. Beyond the visible stars and the globular clusters, the halo also contains something that cannot be seen at all, an unseen mass, whose presence is inferred from the way visible matter behaves, extends through the halo in a distribution that reaches far beyond even the outermost stars. This diffuse, invisible presence makes up the majority of the halo's actual mass. It simply exerts its influence, holding the outer structure of the galaxy in place, keeping the disk from dispersing outward, shaping the paths of everything that moves through the halo's wide and quiet spaces. The halo, in this sense, is less a visible structure and more a gravitational environment, a vast, roughly spherical region of influence that extends far beyond what any telescope can resolve into individual components. The stars and clusters within it are almost like markers, scattered through a much larger presence that remains entirely hidden. They reveal its shape only indirectly, the way the motion of leaves reveals the presence of a wind that cannot itself be seen. Somewhere within the halo, at distances that place them well beyond the main disk, there are also smaller satellite systems, dwarf galaxies that have been slowly drawn into the Milky Way's gravitational reach over long periods of time. Some of these are so diffuse and faint that they were only identified in recent decades, as survey instruments became sensitive enough to detect their sparse stellar populations against the surrounding sky. They drift in wide orbits, some of them gradually losing stars to the larger galaxy's pull, leaving behind faint streams of stellar material that trace their paths through the halo like something slowly dissolving. These streams are among the quieter pieces of evidence that the galaxy's outer regions are not entirely still. Even in the halo, even among the oldest stars and the most ancient clusters, there is slow movement, slow change. Material is still being gathered. Orbits are still shifting, over timescales so long they are invisible to any individual observer, but real nonetheless. The halo connects outward to something even less defined, a region where the galaxy's influence gradually fades and gives way to the intergalactic space beyond. There is no sharp boundary, no clear edge where the Milky Way ends and the emptiness between galaxies begins. The transition is gradual, the stellar density declining slowly, the gravitational influence softening with distance until it becomes indistinguishable from the larger-scale structure of the universe around it. That gradual fading at the edges is its own kind of image, the galaxy not ending so much as slowly becoming something else, its influence softening into the wider environment, the way a sound gradually becomes too faint to hear. The organized structure at the center, the disk with its arms and its ongoing activity, the halo with its ancient stars and its invisible mass, all of it eventually gives way to the vast and mostly empty space between one galaxy and the next. And in that space between, there are other structures worth turning toward. The way the Milky Way itself is arranged within its larger neighborhood, the other galaxies nearby, and the slow and intricate patterns of how they all relate to one another, across distances that make even the halo seem close and familiar. The Milky Way belongs to a gathering of galaxies that move together through space, a loose and slowly shifting collection that astronomers call the local group. It is not a tight cluster, not a dense arrangement of galaxies pressed close to one another. It is more like a wide, quiet neighborhood, with long distances between its members and no sharp edges defining where it begins or ends. The two largest members of this neighborhood are the Milky Way and Andromeda. They are the dominant presences, each surrounded by their own smaller companions, each holding a gravitational influence that extends far out into the surrounding space. Between them and around them, dozens of smaller galaxies drift in orbits that take billions of years to complete. some of them barely more than loose collections of a few 100 million stars, faint and diffuse, easy to overlook against the wider sky. The local group itself is not isolated. It sits within a much larger arrangement, a vast web-like structure of galaxy clusters and filaments that stretches across hundreds of millions of light-years. The Milky Way is part of a supercluster, a gathering so enormous that the word enormous no longer carries much meaning. Within that supercluster, the local group occupies a relatively quiet region, away from the densest concentrations of galaxies, somewhere near the outer reaches of a larger gravitational system, whose full extent was only mapped in recent years. Sitting with that for a moment, the galaxy that already felt too large to hold in the mind is itself a small part of something far larger, which is itself a small part of something larger still. The scale does not compress into anything manageable. It simply continues outward, one layer of structure beyond the next, each one dwarfing the one before it. And yet the Milky Way remains the place where all of this begins, the home from which everything else is observed, the single vantage point from which one species has gradually, patiently pieced together a picture of a universe they will never fully cross. The view from inside is always partial, but it is the only view there is. In that wider arrangement, the local group nested within its supercluster, the supercluster woven into the larger web of cosmic structure, there is a pattern that becomes visible only when the scale is held very still and considered from a distance. The universe, on its largest scales, is not smooth. It is not evenly filled with matter the way a glass of water is evenly filled with water. Instead, it has texture. There are long filamentary threads where galaxies gather and cluster, and between those threads there are vast hollow regions, enormous voids where almost nothing resides. The galaxies are not scattered randomly through space. They are arranged along the surfaces of these voids, the way foam arranges itself along the edges of bubbles, each bubble pressing against the next, the material gathering at the boundaries, while the interiors remain mostly empty. This large-scale structure, sometimes called the cosmic web, emerged from conditions present in the very early universe, when the distribution of matter was not quite uniform. There were regions slightly denser than their surroundings, and regions slightly less so. Over billions of years, gravity amplified those small differences. The denser regions drew more material inward, and the less dense regions grew emptier as matter flowed gradually away from them. What began as the faintest of variations slowly resolved into the filaments and voids and clusters that can now be mapped across the observable universe. The Milky Way sits within one of the quieter regions of this web, not at the heart of a great cluster, not along the most densely populated filaments, but somewhere in a relatively open space. The supercluster it belongs to is known as Laniakea. It was only fully described in the early years of this century, when astronomers mapped the flow of galaxies through the surrounding space, and found that the Milky Way, along with hundreds of thousands of other galaxies, all share a slow drift toward a gravitational center within that supercluster. Laniakea stretches across roughly 500 million light-years. The Milky Way sits near its outer edge. Even the galaxy's position within the universe is not fixed in any simple sense. The Milky Way is moving, not only in its orbit around the center of its own structure, not only as the solar system completes its long, slow circuit, but also as part of this larger drift, hundreds of thousands of galaxies moving together through space, flowing gradually toward a region of greater gravitational concentration. The motion is slow by any everyday measure, but it is real, and it has been traced through the careful mapping of how light from distant galaxies is shifted by their movement relative to our own. There is something quietly humbling in that image, the galaxy itself in motion, carried along by forces operating at scales so vast that the galaxy's own internal structure, its arms and its center and its halo, are almost too small to register. The Milky Way is enormous beyond any ordinary sense of the word, and yet it is also a small thing, drifting slowly within something far larger, which is itself drifting within something larger still. Coming back inward from that, returning from the scale of superclusters and cosmic filaments to the scale of the galaxy itself, there is one aspect of the Milky Way's nature that sits at the intersection of what is known and what remains genuinely open. The age of the Milky Way as a whole, and the question of how it formed, is something astronomers have approached gradually and carefully over many decades. The oldest stars, in the outer regions of the halo formed very early in the universe's history, within the first few 100 million years after the universe itself came into being. These stars carry within their compositions a record of the conditions that existed when they formed, when the universe was still very young, and the heavier elements now so common had not yet been widely distributed by the endings of earlier stellar generations. Those earlier stars formed from material that was almost entirely hydrogen and helium, the two lightest elements, the ones that emerged from the first few minutes of the universe's existence. There was almost nothing else. The heavier elements, carbon, oxygen, iron, everything that makes up the rocky planets and the bodies of living things, had to be forged inside stars and then scattered outward. When those stars ended their lives, the first generation of stars was born into a universe that contained almost none of those heavier materials. They burned through their fuel and ended. And in ending, they seeded the surrounding space with the elements that the next generation would incorporate. The Milky Way's formation was part of this gradual process. In the early universe, small concentrations of matter collapsed under their own gravity and formed the first structures. These early structures merged and gathered over long periods of time, drawn together by gravity, building into larger and larger systems. The halo of the Milky Way, with its ancient stars and its ancient clusters, preserves something of that early phase, before the flattened disk had fully formed, before the spiral arms had developed their present shape. The halo is, in a sense, a remnant of an earlier stage of the galaxy's existence, a record of what things looked like before the disk settled into the configuration it holds now. The disk itself formed later, as gas that was still flowing inward gradually lost energy and settled into a rotating plane. Star formation in the disk has continued ever since, at varying rates, with periods of greater activity and periods of relative quiet. The spiral arms are not fixed structures. They are more like waves moving through the disk, regions of slightly greater density, where gas is compressed and star formation is encouraged. Stars form within the arms, move through them, and emerge on the other side, continuing their orbits around the galactic center, independent of the arm's position. The spiral pattern is somewhat like a slow-moving wave passing through a medium, the medium being the disk of gas and stars, the wave being the density variation that produces the visible arm structure. Stars do not remain within the arms indefinitely. They pass through, and the arms persist because new material is always entering from one side as old material exits from the other. The solar system has passed through spiral arms many times over its long history. The effects of those passages are not entirely certain. There are suggestions that increased rates of nearby star formation during arm crossings may have influenced the flow of cosmic radiation reaching the inner solar system, and that this may have had effects on the Earth's climate over very long timescales. These are connections that are suggested by the patterns but not yet fully established. What is more certain is that the solar system's position within the disk has changed continuously over its history, and will continue to change. The current location between two of the main spiral arms, in a relatively quiet region of the disk, is not a permanent address. It is simply where the solar system happens to be in this particular moment of its long orbit, a moment that will give way to other positions as the orbit continues and the arms continue their slow passage through the surrounding disk. And so the Milky Way, considered fully, from its central region with its dense stellar population and its ancient black hole, out through the bar and the disk and the spiral arms, through the thin disk and the thick disk, into the halo with its old stars and its invisible mass, and beyond into the fading outer regions where the galaxy's influence gradually softens into intergalactic space, is not a still object. It is a system in continuous slow motion, changing on timescales that dwarf any human reference point, shaped by forces that operate across distances no individual observer will ever cross. It is also a system with a future, one that has already been partially described, though that part of the story belongs to what comes next. There is something approaching from the direction of the constellation Andromeda, moving steadily through the space between galaxies, following a path that has been traced and measured with considerable care. It is not small, and its eventual arrival will change the Milky Way in ways that are worth considering quietly, without hurry, before the full picture comes into view. Andromeda is a galaxy, a full, vast system of its own, containing roughly 1 trillion stars, held together by its own gravity, shaped into its own spiral form. It has been moving through space along a path that has been carrying it gradually closer for longer than the Earth has existed. The distance between the Milky Way and Andromeda is still very large, around 2.5 million light-years, a span of space so wide that light itself, traveling without pause, would need 2.5 million years to cross it. And yet, by the measures that govern the motion of galaxies, Andromeda is close enough that its approach has been measured, close enough that the shape of what will eventually happen has already been worked out in careful detail. What is coming is not a collision in the way the word usually sounds. The stars within each galaxy are separated by distances so immense that almost none of them will physically meet when the two systems begin to move through one another. The space inside a galaxy is mostly empty, a vast, dim openness with stars scattered through it like grains of dust suspended in a very large room. When Andromeda and the Milky Way finally reach one another, the two systems will pass through each other more like two clouds of mist drifting together than like two solid objects meeting. What will change is the shape of everything. Gravity will pull long streams of stars outward from both systems, drawing them into arcing trails that curve through space in slow, sweeping forms. The two galaxies will pass through each other, separate, and then gradually fall back together, drawn by their mutual gravity. Eventually, after a process that will unfold across billions of years, they will settle into a single merged system, neither spiral any longer, but something quieter and more rounded, a new form shaped from the remnants of two ancient ones. The Sun will almost certainly survive this. The Earth, too, in all likelihood. The solar system will simply find itself in a different place within a different structure, orbiting a center that is no longer quite the same center it has always known. That part of the story is still very far away. For now, the Milky Way continues on as it always has, vast, unhurried, and largely unknown even to the small lives quietly unfolding within it. The merger, when it finally comes, will not arrive as a single moment. It will be something that unfolds so gradually, across such an immense span of time, that no observer within either system would ever witness more than the faintest suggestion of change, a slow rearrangement, a quiet reshaping of something that had always seemed fixed. There is something almost restful in that. The largest transformation the Milky Way will ever undergo will happen in a way that resembles more than anything else, a long and patient settling. But before that distant future arrives, there is still so much of the present galaxy left to consider. The Milky Way as it exists now, not as it will become, but as it is, in this long and unhurried moment of its history, holds details that are worth staying with a little longer. Smaller things, quieter things. The kind of details that do not announce themselves but reveal themselves slowly, the way a dim object becomes visible only after the eyes have had time to adjust. One of those details is the gas. The Milky Way is not made only of stars. Between the stars filling the spaces that might otherwise seem simply empty, there is an enormous reservoir of gas and dust, a diffuse and slowly drifting medium that permeates the entire disk. Some of it is cold and dense, gathered into vast molecular clouds where new stars are still forming. Some of it is warm and thin, spread so finely across such enormous distances that it would register as nearly nothing in any container a person could hold. And some of it is very warm, so energized by the radiation of nearby stars that it glows faintly, spreading a dim luminescence across regions of the disk that would otherwise remain invisible. This interstellar medium is not simply a backdrop. It is the material from which stars emerge, and it is the material to which stars eventually return. When a massive star reaches the end of its life, it releases its outer layers in a slow and expanding wave. Those layers do not simply disappear. They drift outward and gradually merge back into the surrounding medium, enriched now with elements that the star spent its long life slowly building: carbon, oxygen, iron, and others. The medium absorbs these materials, and in time, new clouds form from the enriched gas. Within those clouds, new stars begin their long and slow process of gathering and warming into being. The Sun was made from this kind of inherited material. The carbon woven into living things, the oxygen in a breath, the iron that moves quietly through the blood, all of it was forged inside stars that completed their lives long before the solar system existed. The Milky Way has been returning its own substance to itself across billions of years, each generation of stars building on the material left behind by the one before. There are regions within the disk where this process is more visible than others. The Orion Nebula, which appears as a faint smudge within the constellation Orion, is one such place, a vast cloud of gas and dust where stars are forming at this very moment, condensing slowly from the surrounding material, warming from within, as gravity draws them together. It is one of the nearest regions of active star formation to the solar system. The light reaching the eye on a clear evening has traveled only about 1,300 light-years to arrive. In the scale of the galaxy, that is very near. The Milky Way contains many such regions, scattered through the disk at various distances, each one a place where the galaxy is still in the process of making something new. The disk is not a finished structure. It is a living one, still building, still changing, still adding to the long count of stars that have formed within it over the course of its history. That history stretches back a very long way. The oldest stars in the galaxy formed when the universe was still very young, within the first few 100 million years after the beginning of everything. These are not stars like the Sun. They formed from a medium that had not yet been enriched by previous generations, a medium composed almost entirely of hydrogen and helium, the two simplest elements. Stars made from such sparse material tend to be very massive. They tend to live short lives by stellar standards, burning through their fuel in millions of years rather than billions. Most of them are long gone. But some of the second-generation stars, those that formed from material only slightly enriched by the first, are still burning. They live in the halo, those dim outer regions that surround the disk, moving in orbits that carry them far above and below the plane of the galaxy. They are old in a way that resists easy comparison. The Earth is about 4.5 billion years old. These stars are nearly 3 times older than that. They were already ancient when the solar system first began to form. Looking at one of these stars, if it were possible to simply sit beside one and observe it, would be something like looking at a remnant of the earliest universe. The conditions that produced it no longer exist anywhere in the Milky Way. The galaxy has changed too much. The medium has been enriched. The original simplicity replaced by a complex mixture of elements that accumulated slowly over billions of years of stellar life and stellar death. Those first conditions are gone. But the stars themselves remain, still burning quietly in the outer halo, carrying within them a chemistry that belongs to a much earlier time. The halo itself is a dim and sparsely populated place. Its stars are spread across a region far larger than the disk, arranged not in a flat plane but in a roughly spherical distribution that extends outward in all directions from the galactic center. They do not orbit the way disk stars do, moving in the same direction in roughly the same plane. Halo stars move in orbits tilted at all angles, some of them nearly perpendicular to the disk, some carrying them in the opposite direction from the general rotation of the galaxy. They are a reminder that the Milky Way was not always the orderly structure it appears to be now. In its earliest period, before the disk had fully formed, the galaxy was a more irregular place, and the halo stars still carry the memory of that earlier arrangement in the shapes of their orbits. Woven through the halo, and extending into the disk as well, is the invisible mass that holds everything together. It does not emit light. It does not reflect light. It has no surface, no defined boundary, no feature that any instrument has yet been able to directly observe. And yet it is there, known only by its effect on the stars and gas that move within its gravitational influence. The outer regions of the galaxy rotate at speeds that cannot be explained by the visible mass alone. Something additional must be present, something that contributes gravity without contributing light. The nature of that something remains one of the most patient and unresolved questions in the study of the universe. It is a strange thing to consider that the majority of the Milky Way's mass is made of something that has never been seen, and may never be seen by any method currently available. The galaxy that contains every star ever observed from Earth is itself mostly invisible. The visible portion, all those hundreds of billions of stars, all that gas and dust, all those nebulas and clusters, and the long glowing regions of star formation, amounts to only a fraction of what is actually there. The rest is something else entirely, present only as a quiet and pervasive gravity that keeps the whole vast structure from drifting apart. And so the Milky Way holds, as it always has, shaped by forces that cannot be fully seen, containing histories that stretch back nearly to the beginning of time, still forming new stars from the recycled remnants of old ones, still slowly turning, still carrying the solar system along its long and unhurried path through the disk. There is one more thing worth considering before this picture is complete. Something that has been observed not within the galaxy, but along its edges, in the faint and distant regions where the Milky Way's influence softens and begins to give way to the wider space beyond. Small structures have been found there, and in the halo, that tell a quieter story about where the Milky Way has been and what it has gathered along the way. These structures, faint and scattered, visible only through careful observation over many years, are the remnants of smaller galaxies that wandered too close to the Milky Way long ago. They were not drawn in through anything swift or forceful. They were simply pulled, gradually, by the quiet and overwhelming presence of a much larger gravitational field. Over time, their stars were stretched into long and flowing streams that now arc through the halo like the last traces of something that was once whole. The Sagittarius stream is one of these, a ribbon of stars pulled from a small companion galaxy that has been slowly coming apart over billions of years. Its material winds in a great loop around the Milky Way, above and below the disk, tracing a path that speaks of an encounter still unfolding in slow motion. The source of that stream, the Sagittarius dwarf galaxy, still exists as a loosely bound remnant, though it has lost a great deal of its original mass to the Milky Way's pull. It continues to orbit, growing thinner with each pass. There are other streams as well, other faint arcs of stars moving through the halo in patterns that suggest similar histories. Small structures absorbed so gradually that the process is still ongoing, the boundary between one galaxy and another becoming softer and less defined with every passing age. The Milky Way has not simply existed in isolation. It has been gathering slowly and without urgency, accumulating material from the smaller structures that have come within its reach. This is how large galaxies grow. Not through swift events, but through long and patient accumulation. A process measured in billions of years, visible only in the faint structural traces left behind in the halo. Every stream of stars found there is a kind of record, a slow inscription written across the outer regions of the galaxy by the movement of things that no longer exist in their original form. The Milky Way carries all of this within it, its ancient stars, its invisible mass, its long history of quiet gathering, and it continues moving, as it always has, through a universe still full of things it has not yet encountered. And so the picture that has been slowly assembling itself across all of this, the disk, the halo, the ancient stars, the invisible mass, the long streaming remnants of smaller things drawn inward over time, is not a still one. It never has been. The Milky Way is not a finished object sitting quietly in space. It is something still in motion, still changing, still in the middle of a story that began nearly 14 billion years ago and has not yet reached anything resembling an ending. There is a quality to that. When you sit with it long enough, that begins to feel less like a scientific fact and more like something you can almost sense. The way a river feels different when you understand that the water moving past you has been traveling for a very long time and still has very far to go. One of the things that makes the Milky Way so difficult to hold in the mind is that it exists at so many scales at once. At one scale, it is the faint smear of light visible on a clear evening from somewhere far from city glow. Something a person can look at with bare eyes. Something ancient humans named and wondered about long before anyone understood what it was. At another scale, it is a structure 200,000 light-years across, containing mass so enormous that smaller galaxies are drawn toward it from vast distances and slowly come apart in its presence. Both of these are the same object, the same home. What continues to unfold at the edges of that home is something astronomers have been piecing together only gradually, through observations that required patience and precision in equal measure. The streams of stars found in the halo, those long, faint ribbons pulled from smaller structures over billions of years, are not the only evidence of the Milky Way's slow accumulation. There are also the satellite galaxies themselves, the ones that have not yet been fully absorbed, still orbiting at varying distances, still held to the Milky Way by the same quiet gravitational presence that has shaped everything else in this story. The large and small Magellanic Clouds are the most visible of these, two irregular galaxies that can be seen from the southern hemisphere without any instrument at all, appearing as softly glowing patches of sky, detached and luminous. They are close enough as galactic distances go, that the Milky Way's influence reaches them clearly. A stream of gas connects them to the Milky Way, flowing in a long arc across a vast stretch of sky, material being drawn gradually inward, not yet arrived, still in transit across a distance that light itself would need tens of thousands of years to cross. Whether the Magellanic Clouds are long-time companions of the Milky Way, or relative newcomers that have only recently entered its gravitational reach, is something that has been considered carefully. Measurements of their motion suggest they may be moving too fast to have been in orbit for the full age of the galaxy, that they may have arrived more recently, on their first close approach, still carrying the momentum of a long journey from somewhere further out. If that is the case, then what appears to be a familiar and settled relationship is something much newer, a meeting still in its early stages, the outcome of which will only become clear over timescales that make the current age of human civilization seem like something that happened in a single quiet afternoon. There are dozens of other satellite galaxies as well, most of them far smaller and dimmer. Several were found within the last 20 years, as observational methods became sensitive enough to find structures so faint they had simply been invisible before. It is likely that more remain undiscovered, hiding in the outer halo in forms too diffuse and scattered to have yet resolved themselves against the background. The Milky Way is surrounded by a population of small companions whose full extent is still being mapped, still being understood. Each of these small galaxies has its own history, its own arrangement of stars, its own age and composition. Some are among the oldest stellar environments known, places where star formation essentially ceased very early in the universe's history, leaving behind only ancient, dim stars that have been burning slowly and without interruption ever since. These are called dwarf spheroidal galaxies. They are in some ways the quietest objects in the known universe, not forming anything new, not changing in any visible way, simply persisting, carrying within them a record of conditions that existed when the universe itself was very young. Studying them has offered something valuable, a way of understanding what the earliest building blocks of larger galaxies may have looked like before they were assembled into the structures that exist now. The Milky Way itself, in its very earliest period, may have resembled something not entirely unlike these small companions, a loose and irregular gathering of stars, not yet organized into the disk and spiral structure that would eventually emerge from billions of years of gradual settling and slow rotation. What those early stages looked like in detail is something that can only be inferred indirectly. It comes through the properties of the oldest stars still present in the halo, through the chemical signatures embedded in stellar atmospheres that record what conditions were like when those stars first formed, through the orbital patterns of structures preserved almost without change across enormous spans of time. The galaxy does not keep written records, but it keeps physical ones, encoded in the motion and composition of things that have been moving through it since very nearly the beginning. There is something quietly affecting about that, the idea that the oldest stars in the outer halo are not simply old in the way that a building or a mountain is old, but old in a way that connects them to a period before the Earth existed, before the Sun existed, before most of the matter now present in the visible universe had yet been processed through the interior of any star at all. They formed from the first available material, in conditions that have not existed anywhere in the universe since, and they are still here, still moving through the halo in their wide and tilted orbits, unhurried, indifferent to everything that has accumulated around them in the long interval since. The Milky Way has changed enormously in that interval. The disk formed, the spiral arms developed and shifted. Generations of stars formed and ended. Enriching the stars formed and ended, surrounding gas with heavier elements that made subsequent generations of stars and eventually planets more chemically layered than anything that had come before. The solar system itself is a product of that long accumulation, formed from material that had already passed through at least one previous stellar lifetime, carrying within it the remnants of something older. All of this happened inside a structure that is still moving, still turning, still drawing smaller things toward it, and weaving their material into its own. The Milky Way is not a setting within which other things happen. It is itself a process, ongoing, patient, and vast in a way that resists any attempt to hold it completely in mind. And yet it is also, somehow, the place where everything familiar exists. Every person who has ever lived, every structure ever built, every sound ever made, all of it has happened within this single galaxy, on a single small planet, in a quiet region of the disk, far from the center and far from the edges, in a location that is in no way remarkable, and in every way extraordinary, simply by virtue of being where it is. The night sky that any person can see from anywhere on Earth is a small and partial window into all of this. The stars visible with bare eyes are neighbors, relatively speaking, close enough that their light arrives within years or centuries rather than millennia. The band of softer light that stretches across the sky on clear, dim nights is the disk seen from within, compressed by distance into something that looks almost like a cloud. And beyond all of it, in every direction, the rest of the structure continues. The halo, the satellite galaxies, the streams of stars still moving in long arcs, the invisible mass holding everything in place, the slow and ancient turning that carries the solar system along a path it has followed for as long as the sun has existed. There is still something else to consider. Something that exists not in the quiet past of the galaxy, but in what is slowly approaching from outside it. Something that has been moving toward the Milky Way for a very long time, and whose arrival will be unlike anything the galaxy has experienced in its long history. That something is Andromeda. It has been moving toward the Milky Way for as long as anyone has been able to measure its motion. A vast structure, roughly similar in size to this one, carrying within it hundreds of billions of its own stars, its own ancient halo, its own slow history of mergers and accumulations, stretching back nearly to the beginning. It is approaching at roughly 70 miles per second, which sounds considerable until you consider the distances involved. At that pace it will not arrive for another 4 billion years or so. There is no urgency in this. There is only the slow, patient geometry of gravity, doing what gravity always does, drawing things gradually together across enormous spans of space and time. What will happen when it arrives is something that takes a long time to fully settle into the mind. The word collision is technically fitting, and yet it suggests something this event will not resemble in any ordinary sense. The stars within each galaxy are so widely separated from one another that the two structures will move through each other more like two vast and slowly interpenetrating clouds than like any collision a person might picture. Most stars will never come close to another star from the approaching galaxy. The overall shape of both structures will soften and distort, pulled into long, sweeping arcs and tidal streams by the gravitational interaction, but the individual stars within them will largely continue along paths that simply become more layered, more woven, drawn into new arrangements over millions of years of slow interaction. The two galaxies will move through each other, then fall back together, then move through again, each approach drawing them more closely into a shared structure that will eventually settle into something neither currently resembles, a single, larger, more rounded form, quieter and less organized than either spiral galaxy is now. Astronomers have a name for what will emerge from that long process. They call it Milky Way, a name that holds both histories inside it, the way a river holds the memory of every tributary that has ever fed into it. The sun will still exist when this begins. The earth may still exist, whether anything remains on it, to witness the slow distortion of the night sky, the gradual widening and shifting of the stars overhead, as Andromeda grows from a faint smear into something that fills a wider and wider portion of the visible sky, is a question that opens into its own long silence. The name itself is worth staying with for a moment, Milky Way, before anything else about it is considered. It is not a formal scientific designation. It is something closer to a quiet acknowledgement that two long histories will one day become one. The Milky Way and Andromeda, each carrying billions of individual stellar lifetimes within their structures, will eventually lose the boundary between them entirely. What was once a border, the dim and distant smear of Andromeda visible in a clear night sky, a faint oval of ancient light, will dissolve so gradually that no single moment will mark the change. There will simply be a slow and patient merging, the way two rivers finding each other in a wide valley do not announce their joining. They simply become one moving thing, carrying everything forward together. The night sky during that long process will be unlike anything visible from Earth now. In the early stages of the approach, still hundreds of millions of years before any real interaction begins. Andromeda will have grown from its current faint smear into something noticeably wider and noticeably brighter, a soft and widening presence in the southern sky, not a point of light, not a cloud. Something with visible structure, a shape that resolves slowly over generations into something filling more and more of the overhead dark. The stars within it will not be individually visible to any unaided eye, but the overall glow will deepen and widen with each passing million years. A slow brightening that no single lifetime would ever notice, but that the long accumulation of time would make unmistakable. By the time the two structures begin to genuinely interpenetrate, their outer regions overlapping, their halos already mingling, the night sky will have become something entirely different from what anyone now alive has ever seen. New star formation will be stirred into motion by the gravitational interaction. Gas and dust, compressed by the encounter, will begin collapsing into new stellar structures. Regions of the combined system will glow with the light of formation in a way that neither galaxy currently does across most of its extent. The sky will be richer, more layered with structure that no map made from the present could have anticipated. None of this is violent in any ordinary sense. The word collision, borrowed from the language of things that break, does not quite fit what gravity does across these distances and timescales. It is more like an embrace that takes billions of years to complete. Two vast and ancient structures finding each other across the void, and slowly, through repeated approach and retreat, becoming something neither was before. What is worth holding on to is how little of this involves destruction. The stars within both structures will be redistributed, drawn into new arrangements, their paths altered by the shifting gravitational landscape around them. But the stars themselves will largely survive the process unchanged. A star that formed in Andromeda 3 billion years before the merger will still be burning quietly after the merger is complete, now simply moving through a different region of a larger combined structure, carrying its own long history into a new context. The past does not disappear, it is simply gathered into something wider. The Sun, if it still exists during the early stages of this encounter, will likely find its position within the combined structure, shifted, moved outward or inward, from wherever it currently sits, drawn along a new path by the altered gravitational arrangement around it. The changes will be real, but gradual, unfolding across spans of time that make even the current age of the solar system seem brief. The solar system will move as it has always moved, following whatever gravitational path surrounds it, simply within a larger and more complex landscape than the one it currently inhabits. What will eventually settle from all of this is the structure astronomers call Milky Way, a single, large, more rounded form, quieter in its overall shape than either of the two spirals currently are. Spiral galaxies carry their form partly because of the way they rotate and the way their gas and dust is distributed in a relatively organized disk. The long process of merging tends to disrupt that organization, drawing material into wider and more complex arrangements, until the resulting structure loses the elegant sweep of spiral arms. What remains becomes something more diffuse, more elliptical in shape, a vast and slowly dimming collection of older stars, most of the gas that once fueled new star formation, having been used or dispersed during the long interaction. Elliptical galaxies, the form that Milky Way is expected to eventually resemble, are in some ways the quieter end of galactic life. They are not still, but they are slower, less actively forming new stars, more settled into a long and gradual aging, their light coming mostly from older stellar populations, burning with a warm and reddish glow, rather than the blue brightness of newly formed massive stars. They are what galaxies often become after the more active, more organized phases of their lives have passed. Something patient and vast, and no longer in a hurry. The Milky Way has already been through smaller versions of this process. The streams of stars that trace long arcs through the outer regions of the galaxy, remnants of smaller structures absorbed over billions of years, are evidence of mergers that happened long before the present. Sagittarius, a small galaxy currently being drawn apart by the Milky Way's gravity, is adding its stars to the outer disk in a process that has been ongoing for hundreds of millions of years. The Milky Way has been gathering and merging throughout its history. What is approaching from Andromeda is simply the largest such encounter it has yet faced, a meeting between near equals rather than between a large structure and a small one. There is something in that scale worth sitting with. Two galaxies of comparable size, each carrying a supermassive structure at its center, each surrounded by its own invisible halo of mass, each with its own long history of formation and merger and slow evolution, finding each other across a distance that currently measures roughly 2.5 million light-years. The two central structures, Sagittarius A/SLA at the heart of the Milky Way and the supermassive region at the heart of Andromeda, will themselves eventually settle into a shared orbit. They will circle each other in a slow and tightening spiral, before finally merging into a single larger central mass at the heart of the combined galaxy. That final merging of the two central regions will be one of the most energetic events in the local universe for a very long time. But even that will unfold slowly, by any measure that matters to the structure around it. Gravity does not rush, it simply continues, patient and steady, drawing things together along paths that were set long before any of the individual stars now moving within these two galaxies had yet formed. All of this is still 4 billion years away. The number is large enough that it resists any real emotional weight on its own. But there is something in knowing that the process is already underway, that Andromeda is already moving, has always been moving in this direction, and that the faint smear of light visible in a clear autumn sky from the northern hemisphere is the earliest and most distant view of what will one day become part of the same structure that contains the Sun. It is already, in the slowest possible sense, arriving. The Milky Way exists within a larger neighborhood of galaxies, a loose cluster of structures bound together by gravity, moving through the wider universe as a group. And that neighborhood itself exists within something even larger, a vast web of filaments and voids that stretches across scales so enormous that individual galaxies become nearly invisible within them. Points of light in a structure so wide that the word structure barely applies. The filaments are perhaps the most quietly astonishing structures in the known universe. Long, web-like threads of matter stretching across hundreds of millions of light-years, connecting clusters of galaxies, the way rivers connect distant lakes. They are not solid. They are not dense in any way that would be visible from within them, but they are real, and they are the reason the universe looks the way it does at the very largest scales. Not a smooth and even distribution of matter, but something more like a vast and intricate foam, with galaxies gathered along the edges of enormous hollow voids that contain almost nothing at all. The Milky Way sits within one of these filaments, embedded in the local group of galaxies. That local group is itself part of a larger supercluster that astronomers named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea spans roughly 500 million light-years. It contains the mass of 100 million billion suns, distributed across thousands of individual galaxies. All of them are moving slowly, steadily, toward a gravitational center that astronomers call the Great Attractor, and the Milky Way is moving in that direction now, drawn along with everything else in the supercluster, following a path it did not choose and cannot resist. The Great Attractor itself is difficult to observe directly, because it sits almost exactly behind the densest part of the Milky Way's own disk, hidden behind the dust and gas of the plane of the galaxy, in a region astronomers call the zone of avoidance. For a long time its presence was known only through the motion of everything around it, the way a current in deep water can be inferred from the movement of everything floating slowly on the surface above. Only through radio and infrared observations, which pass more freely through the obscuring material, has it become possible to see something of what lies there, a dense concentration of galaxies and mass, drawing the local universe gradually inward, over timescales that dwarf even the coming encounter with Andromeda. All of this, the filaments, the voids, the slow convergence toward distant gravitational centers, the vast hollow architecture of the universe at its widest scale, exists around the Milky Way, the way an ocean exists around a single wave. The galaxy is real and enormous and ancient, and yet within the full geometry of what surrounds it, it is something very small, moving very slowly, through a structure so wide that no word for it has yet been found, that feels sufficient. The story of the Milky Way does not end at its edges. It opens there, into something wider still. There is a version of you that existed 225 million years ago. Not you, not anything like you, but the matter that would eventually become you, scattered across the cosmos, in forms that had not yet imagined life. The solar system was somewhere else in the galaxy then, completing what would become the previous lap of its long orbit, moving through regions of space that no human instrument has ever mapped. The Earth existed, already ancient by some measures, already carrying the early shapes of life in its oceans and shallow seas. And the position in the galaxy that you occupy right now, on this evening, in this quiet moment, that position was empty. It will be empty again, long after everything that currently exists here has moved on. Some future arrangement of matter will pass through this same location, unknowing, carrying its own brief moment of awareness, through a place that once, for a while, held something that could look upward and wonder. This is one of the quieter things about living inside a galaxy. The address is temporary, not in any way that matters within a human life, or a civilization, or even the full span of the species, but in the longer arithmetic of the universe, every position is borrowed. The Milky Way has been slowly gathering its current shape for most of the age of the universe itself, not all at once, and not through a single steady process, but through a long series of events, mergers, absorptions, the gradual drawing in of smaller structures that wandered too close and were softly folded into the whole. There are streams of stars within the galaxy that trace the paths of ancient dwarf galaxies, consumed so long ago that the galaxies themselves are gone, dissolved entirely into the larger structure. What remains of them are only these faint ribbons of stars, moving in patterns slightly different from those around them, like the last visible trace of something that no longer exists in any other form. One of these streams, known as the Sagittarius stream, winds around the galaxy in a long and looping arc. It is the remnant of a dwarf galaxy that has been passing through the Milky Way for billions of years. Each passage stripped away more of its stars, scattering them in a trail that now wraps around the outer regions of the disk like a thread wound loosely around a sphere. The Sagittarius dwarf galaxy still exists, in a diminished form, but it is being gradually absorbed, a process so slow that the word gradual barely contains it, and yet one that is measurably underway. The galaxy remembers what it has consumed this way, not in any conscious sense, but structurally, in the motion of stars that still carry the orbital signature of the thing they once belonged to. Astronomers can read these signatures, tracing the paths of stars that move slightly differently from their neighbors. From those paths, something of the history of what arrived and was folded in can be reconstructed, long before any eye existed to observe it. The disk of the Milky Way is not perfectly flat. It warps toward its outer edges, bending gently in a shape that curves one side slightly upward and the other downward, like the brim of a hat that has been worn for a very long time. The cause of this warp is not entirely settled. One possibility is that it reflects the influence of the Magellanic Clouds, two smaller companion galaxies that orbit the Milky Way at a distance, pulling on the outer disk as they move, leaving a slow and lasting impression in the structure of the whole. The Magellanic Clouds are visible from the southern hemisphere as two faint separate patches of light. They are the nearest neighboring galaxies to our own, close enough that they are gravitationally bound to the Milky Way, following long orbits around it, the way moons follow planets. The large Magellanic Cloud sits roughly 160,000 light-years away. The small Magellanic Cloud lies a little further still. Both are irregular in shape, full of young stars and regions where new stars are still forming, and both are being drawn gradually closer over timescales that extend far beyond anything a human frame of reference can comfortably hold. There is a bridge of gas and stars connecting the two Magellanic Clouds, a faint and narrow stream of material stretched between them, evidence of their long gravitational relationship with each other and with the Milky Way. It is called the Magellanic Bridge. It is one of the quieter structures in the local neighborhood, not dense, not vivid, but real and traceable, a sign of the slow forces that are always at work between things that are close enough to feel each other. The Milky Way is, in the end, a living structure, not in any biological sense, but in the sense that it is always changing, always processing, always drawing in and rearranging, and slowly becoming something slightly different from what it was. New stars are forming within it right now, condensing out of cold clouds of gas in the spiral arms, following the same process that formed the Sun 5 billion years ago. They are building toward the same long sequence of nuclear burning that will sustain them for millions or billions of years before they, too, exhaust what they have and return their material to the space around them. Old stars are ending within it right now as well. some quietly contracting into dense remnants that will cool over timescales longer than the current age of the universe. Others more visibly, in the slow expansion of outer layers that were once the star's atmosphere, drifting outward into the surrounding space as a softly glowing shell, a planetary nebula, faint and luminous, before it too disperses and fades. The material from these endings does not disappear. It rejoins the interstellar medium, the vast and diffuse reservoir of gas and dust that fills the spaces between stars, waiting to be gathered again into something new. This is the cycle the galaxy has been running since its earliest stars formed near the beginning of everything. The same atoms have been through multiple generations of stars. The calcium in a human body was forged inside a star that ended before the sun existed. The iron was scattered by an explosion so enormous that for a brief time it outshone everything around it. The oxygen was released into the interstellar medium and drifted for millions of years before gravity gathered it again into the cloud that became the solar system, the planet, the ocean, the cell, the breath. The Milky Way made all of this, not with any direction or purpose, but through the patient operation of physics across time, through gravity and pressure and heat and the slow chemistry of stellar interiors. Every element heavier than hydrogen and helium was built inside a star, or in the final moments of a stellar ending, and then released into the galaxy to be used again. The galaxy is, among other things, a place where simple matter has been steadily transformed, over 13 billion years, into everything that exists here now, and you are here now, inside it. On a clear night, if the conditions are right and the sky is dim enough, a faint band of light can be seen arching overhead. The combined glow of hundreds of millions of distant stars, too far and too faint to resolve individually, blending into something soft and continuous. That band is the disk of the galaxy seen from within, the accumulated light of your neighborhood, stretching from horizon to horizon. It is not a photograph. It is not a representation. It is the thing itself, arriving after traveling distances that have no comfortable human equivalent, from sources that have been burning for longer than the Earth has existed. You are not observing the Milky Way from a distance. You are inside it, made of it, looking outward through it, at the wider universe beyond, the structure that surrounds you on all sides, the disk, the halo, the spiral arms winding slowly outward, the ancient stars in the outer reaches, still burning in the long aftermath of the universe's earliest moments. None of it is separate from you. It is the context in which you exist, the medium through which the atoms that form you were made and scattered and gathered and made again. There is no outside view. There never will be. But there is this, a quiet evening and a faint band of light overhead, and the knowledge that what you are looking at is not a distant thing, but the body of the place you have always been. The Milky Way carries a chemical signature threaded through the interstellar medium, not one any living thing could sense directly, but one that astronomers have slowly traced. Molecules of extraordinary complexity drift through the spaces between stars, alcohols, simple sugars, amino acids in their most elemental forms, suspended in clouds so vast and so cold that they seem like the last place anything could ever come together. And yet within those clouds, chemistry is happening, slowly, over millions of years, on the surfaces of tiny grains of dust. Molecules are assembling into forms that would not look entirely unfamiliar to a chemist on Earth. The interstellar medium is not a void. It is a medium in the truest sense, something through which things pass, and within which things form, a diffuse and patient environment, where the preconditions for complexity have been accumulating since long before the Earth was here to receive them. The space between stars is full of material in motion, drifting and gathering, and slowly becoming. Some of those molecules arrive on planets. They travel inside comets and asteroids, frozen and preserved across the long journey. And when those objects meet a world with the right conditions, they deliver what they carry. The Milky Way has been seeding its planets this way for billions of years, not with any aim, but as a natural consequence of the same processes that form stars and scatter their remnants and gather them again. The galaxy is older than it knows how to tell us fully. Its earliest stars left only traces in the chemistry of what came after, in the subtle patterns of how later generations of stars are distributed, in the faint gravitational memory, written into the motions of things that are still moving now. 13 billion years is not a number the mind can hold. It is more useful simply to remain with the fact that the Milky Way was already ancient before the sun arrived, and that the sun itself has been here long enough for life to emerge, grow slowly more complex, and eventually look upward and begin to wonder. That wondering feels like the most natural thing. One small part of the galaxy becoming aware of the whole, however partially, however briefly, in the long and quiet dark. That is enough. More than enough. It is, in the end, everything. Thank you for being here tonight. Good night.